So we have seen that GSHS equal to 1 upon J omega into J omega t plus 1. This is the transfer function, open loop transfer function. And we have already seen at omega equal to 0 and at omega equal to infinity. So see now at omega equal to 0, magnitude is infinite at minus 90 degree. So from this 90 degree, minus 90 degree, minus the infinity value is coming. That is, it touch on the infinite value and it start moving towards the 180 degree. Sorry, minus 180 degree, and it reached to this value. See, the Nyquist plot is drawing from omega equal to 0 to omega equal to infinity. So this is representing at omega equal to 0 and this is representing at omega equal to infinity. At omega equal to infinity, magnitude is 0, but angle is minus 180 degrees. So at the minus 180 degree, the magnitude becomes 0. At omega equal to 0, magnitude is infinity where it is at minus 90 degrees. So thus negative will is touching minus 90 degrees. So moving from here towards the minus 180 degrees. So this is the rough plot. Now draw the mirror image of this. This is the mirror image. And this is showing at omega equal to minus infinity. This is omega equal to minus infinity. And this is present at omega equal to minus 0. Now it is required to draw the Nyquist contour for this plot. So we know we have seen already here, this is equal to how much? S into ST plus 1. So this is showing the type of the system, in the denominator, the value of the power of S is representing the type of the system. So the power of S is 1. Maximum power of S is 1. So this is the type 1 system. For the type 1 system, the Nyquist contour is required to encircle the plot by minus pi, that is minus 180 degree. So this is the semicircle with radius infinite. So it is drawing from omega equal to minus 0 to omega equal to 0. So from here, the Nyquist contour is drawing, which is a semicircle with radius infinite. So see, this is the Nyquist contour. The radius is considered infinite here. So it is required to see now whether this plot, complete plot, is encircling the origin of the GSHS plane. This is equal to minus 1 plus J0. So let this be the minus 1 value. Now you can see the plot starts from omega equal to 0, from somewhere from infinite, moving towards this, and then touches here and moving here, and then going through the Nyquist contour and completes here. But it is not going to encircle this minus 1 plus J0. So the value of n is equal to 0. The number of encirclements of the Nyquist plot from minus 1 plus J0, this is equal to 0. So now the P is the number of poles present on the right hand side of the S plane for GSHS. Now you can see at the location of poles. The poles is what? Poles are the roots of the denominator of GSHS. So here the poles positions are at S equal to 0 for this, and for this ST plus 1 equal to 0. So the value of S is equal to how much? Minus 1 upon T. So at S equal to 0 and at S equal to minus 1 by T, poles are present. So the poles are not present on the right hand side of the S plane. So this is also equal to 0. Now we know that the principle of argument n equal to P plus minus Z plus. Now put the value of n here. This is equal to 0, equal to, put the value of P plus here, minus Z plus. So the value of Z plus is equal to 0. That is, number of zeros on the right hand side of the GSHS plane are equal to 0. So these zeros of the GSHS are actually the poles of the 1 by 1 plus GSHS, that is of closed loop system. So the poles are not present on the right hand side, or we can say the zeros of the GSHS of open loop transfer function are not present on the right hand side of the GSHS plane. So the system is stable. If the value of Z plus is 1, 2, 3, and so on, then the system will be unstable, which represent the number of zeros of open loop transfer function are present on the right hand side. So the system becomes unstable, but here you can see Z plus is equal to 0. So number of zeros on the right hand side of GSHS plane are 0. So system is stable. So this completes this lecture. Thank you.